Hey guys, today we are going to be working on the unit circle. So this circle over here with all of the different numbers and pies and fractions and coordinates and all of that, that's the unit circle. That's what we're looking at. And you can basically just use the unit circle to find like some different trig values like sine, cosine, and tangent if you're like in a hurry and you want to find a specific trig value. So all of the numbers that are on here are just particular degrees or radians, which we'll talk about that show up a lot whenever you're using sine, cosine, and tangent. So, the first thing to note about this is that this point here is the coordinate 1, 0. That point is where it starts. So, this is the start of the unit circle, and it goes around counterclockwise, and so it just keeps going all the way around until it gets back to that start point, and it ends at the same place. So it's going to start and end at 1, 0. And you just go around counterclockwise as you're looking at it. So the unit circle at each point has 3 different values. The first value is radians. And the way to distinguish radians from other things is it has pi in it. And so it's all of these like different fractions. So pi over 6, pi over 4, pi over 3, all of those are called radians. And then in the entire unit circle, it has 2 pi radians. And then another way to think about radians is 1 radian, so this will give you the idea of like what the measure is going to be equal to 1 radius of the circle. So a radian is going to be equal to whatever the radius of the circle is. In this case, it's from the center, that's the origin 0, 0, to 1, 0, so the radius is just 1 for the unit circle. But that's what the measure of a radian is it's just the same as the radius. So then for degrees, that is all of the ones that have the little degree after it. So like 0 degrees, 30 degrees, 45. And then in the total circle, it goes from 0 degrees to 360 degrees. And then the last thing is all of these different coordinates. So like the 1, 0, the square root of 3 over 2, and 1/2, and all of that. So for each of these coordinates, it's... Oh, I wrote the wrong thing. Hang on. For each coordinate, the x value is actually cosine. I was about to write sine. Is the cosine at that point, and the y value is the sine. So, like, for example, if you had something that asked for the cosine at 30 degrees, then you would look at where 30 degrees is on the circle, you would go to the coordinate, and then the cosine is going to be the x value. So it would end up being the square root of 3 over 2. And so that's kind of how you're going to use the unit circle, is it'll give you either a radian or a degree in most cases, and you look around the circle to find that and then answer what it's asking for. Okay, so now we're going to start doing something. We're going to like rewrite degrees as radians using the unit circle. So the first one that we have is 90 degrees. So you would look around the unit circle until you found 90 degrees, and then you would look for the radian. Remember, the radian is the one with pi. So the radian at 90 degrees is going to be pi over 2. So the next one is 150 degrees. So if I look around the unit circle to find 150 degrees, which is right there, I look for the number that has pi in it, and it would be 5 pi over 6. And the last one that I have is 225 degrees, which is down here at 5 pi over 4. So that part is simple enough. You just find the degrees and then rewrite it as a radian, and it should be about the same for transferring radians into degrees. And then there's also, if you're ever for some reason given a degree that is not on the unit circle, then the formula for transferring it into a radian would be whatever degree you're given divided by 360, because that is the whole circle, and then you would multiply it by 2 pi, because that will transfer into radians for you. So if you're ever given a degree that you can't find on here, like 27 or something like that, you would just use this formula to rewrite it as a radian. Okay, so this next part is really similar and equally easy. You're given the radian and you have to write it as a degree. So the first one that we're given is pi. So just go to the unit circle and find where pi is and then rewrite it as whatever degree is at that point. So for pi, it's going to be at the same point on the unit circle as 180 degrees. The next one we're given is 5 pi over 6. So if we look around, we find that here. And as a degree, that's 150. And the last one is 3 pi over 2, which is down here at 270 degrees. And then, so similarly, there is a formula in case you're given something that is not on the unit circle. So this one is going to be the radian that you're given divided by the total number of radians, which is going to be 2 pi, and then you're going to multiply by 360 degrees. So it's similar to the last formula, it just kind of switches the 2 pi and the 360 depending on what you want to change it into. Okay, so the next part you have to think about just a little tiny bit more. So this is finding trig values. So you're either going to be asked to find the sine of something or the cosine. Just remember that you're using the coordinates to do that, and the x value is going to be the cosine, and the y value is going to be the sine. So for the first one, you're asked for the sine of 120 degrees. So you're going to find 120 degrees on here, and then you're looking for sine, so you have to look at the coordinate, and remember that sine is the y value, so it's going to be the square root of 3 over 2. So for sine at 120, you end up getting the square root of 3 divided by 2. The next one asks you for the cosine at 5 pi over 6. So, and notice that it can ask for it in degrees or radians. So this one's asking for it in radians. So you find 5 pi over 6 radians, go to the coordinate, and then since you're looking for cosine, you're going to use the x value. So that one is going to be negative square root of 3 divided by 2. And our last one is asking for sine again, and this one is at pi over 4. So I'm going to go to pi over 4 on the unit circle, just look around until you find it, and we need to go to the coordinate, and this time, since it's sine, you're going to want the y value. And in this one, it wouldn't really matter because they're the same thing, but still make sure you're looking at the right coordinate. And so that one is the square root of 2 divided by 2. And that's kind of how you do the trig values. Just make sure you're using the right coordinate, whether it's x or y. And the last thing we're doing is sometimes it'll give you the degree or radian in like the negative version of it. So that's what we're going to do now. There's a couple of different ways to do this. If you're given the degree, if it's the negative version, instead of going around counterclockwise, you would kind of just be going around clockwise. So you could do 360 minus the degree, and then that will get you to whatever point you're at. If you're given the radian, it's the same situation. Instead of going counterclockwise, you're going clockwise. So you can do 2 pi minus the radian, and that'll get you to the correct radian. But this method can be a little bit tricky because you end up having to do like subtracting some fractions, and you have to find common denominators and all of that. So there is another method as well. So if you're finding negative values, what you can do is find the original value and then flip it over the x-axis. So just like with graphs, whenever you put a negative out front, it flips it upside down. So let's use an example of the first one, the radian at negative 60 degrees. So just go to positive 60 first, which is right here at pi over 3. And then we're going to flip it over the x-axis. So we're just going to go directly across the x-axis, whether that's up or down, and we end up at 5 pi over 3, or at 300. So if you were using the 360 rule, it would have been 360 minus 60, and you still would have ended up at 300 degrees. So the radian there is 5 pi over 3. So then the next one is where it gets a little more tricky. If you're looking for the degrees at negative 7 pi over 6, you'd be doing 2 pi minus 7 pi over 6. And then that's not too bad. You just have more room for error because you're subtracting fractions. So instead, I'm going to go to negative 7 pi over 6, which is down here. And I'm just going to flip over the x-axis. So I'm just going to look straight up from where I'm at. And I end up at 5 pi over 6, and then it wants the degrees, so I'll be looking at 150. So then the last one, we have negative 3 pi over 4. So I'm going to come to positive 3 pi over 4, flip across the x-axis, and I end up at 5 pi over 4. And then it wants the sine and cosine, so I'm going to be using this coordinate. So remember, cosine is x value, so the cosine of negative 3 pi over 4 is going to equal that x value, which is negative square root of 2 over 2. And then the sine of negative 3 pi over 4 actually ends up being the same thing of negative square root of 2 over 2. But that's just a coincidence. It doesn't always end up being the same thing whenever it's negative or anything like that. That just happens to be the coordinate in that scenario. So that is basically how to use the unit circle. I think I do want to add one more thing on the next slide, but this covers the basics at least. Okay, so one more thing that you might encounter is multiples of values on the unit circle. So what I mean by that is that you might be given something that's like bigger than 360 or 2 pi, which goes further than around the unit circle one time. So what happens, like on the first one, you're finding the radian at 585 degrees. So obviously 585 is not on the unit circle because it only goes up to 360. So what you're going to do is you're going to subtract one full unit circle. And then to determine whether you're doing that in radians or degrees determines in what you're given. So obviously you're not going to subtract 2 pi from 585 degrees because it's already in degrees, so just use 360. So what I'm going to do is 585 minus 360. And when you subtract that out, that's going to get you back to 225 degrees. And so then you're going to go to the spot on the unit circle where that appears, and you see that the radian is 5 pi over 4. So the answer to that would just be 5 pi over 4. But you have to get it down to a degree that is on the unit circle before you can answer it. So for the next one, it's find the degrees at 7 pi. So now I'm going to subtract one full circle in radians, which is 2 pi. So I'm going to do 7 pi minus 2 pi. That's going to get you to 5 pi. But then 5 pi isn't on the unit circle either, so I need to just keep subtracting until I get back to something that is. So I have 5 pi, and I'm going to subtract 2 pi again. And then I get 3 pi. So 3 pi isn't on the unit circle, so I'm going to do it one more time. So 3 pi minus 2 pi is going to get us back to just regular pi. So then whenever I have pi, I'm going to look for that on the unit circle, which is here. And the degrees there is 180. So whenever you're writing 7 pi in degrees, you should get 180. And then the last one is asking you for the sine at 900 degrees. Remember, sine is going to be the y value. So we have like the x value is cosine, y value is sine. So we're going to use that once we get back to a degree that we can use. So first, I'm going to do 900 minus 360 just to see if we can get back on the unit circle. So 900 minus 360 is going to give us 540. Well, that's still more than 360, so I need to subtract it again. So 540 minus 360 is going to give me 180. So that is on the unit circle. It's right here again, where we just were at pi. So now I need to find the sine value at 180. And so what I'm going to do is I'm going to look for that y value, which in this case is 0. So the sine of 180 or the sine of 900 is going to be 0. And that's what you would do whenever you're given multiples on the unit circle. And I just say multiples to show, or like to represent that it's bigger than the values that are on the unit circle. So you have to like subtract one full circle away. So I guess if you want to see like a visual of that, then if I started at like pi and then I added a full circle to it, then I would come all the way back around and I'd be at pi again. So that would be like pi plus 2 pi, which would be at 3 pi. So pi can be like 3 pi, 5 pi, 7 pi. It can be any multiple of 2 pi. Or if you were at 0, then it could just be like 0, 2 pi, 4 pi, and so on. So that's just kind of like if you were actually going around and around and around the circle, then it would be like starting at 0, go around once and you're at 2 pi, go around again and you're at 4 pi, and so on. So, but that would be how you do it mathematically, is what's shown over here. So hopefully that helps, and I think that's about it and all you need to look at stuff on the unit circle.